Hello everyone, this is part 6 video on past year NEET questions from the topic Chemical Kinetics. We'll start with a question that has come in the year 1999. For a first order reaction, the half-life period is independent of. If you look at the options, they are saying first power of final concentration, cube root of initial concentration, and square root of final concentration. So here when we look at the first order reaction, the rate expression will be K is equal to 2.303 divided by T into log of A naught by A. This is the integrated rate expression for the first order reaction. And from here, if you look at the half-life, that essentially means the final concentration will be half of the original concentration. So we'll get the T half value as a standard formula 0.693 by K, and we see that this will be independent of the initial concentration, because when we talk about the half-life of other order reactions, whether it is zero order or second order or even third order, etc., they all will be depending upon the initial concentration of the reactant A naught. So for any general reaction, we see that T half will be proportional to A naught power 1 minus N, where N will be the order of the reaction. So for the first order reaction, the half-life period will be independent of the initial concentration. Correct answer is option C. Next we have a theoretical question. Activation energy of a chemical reaction can be determined by. So if you look at the Arrhenius expression, log of K2 by K1 will be equal to EA by 2.303 R into T2 minus T1 by T2 T1. So we can also express it as log of K2 by K1 will be equal to EA by 2.303 R into 1 by T1 minus 1 by T2. Now if you look at this Arrhenius expression form, where we are relating the rate constants at two different temperatures, the value of EA can be directly obtained from this particular equation if we know the K1 and K2 values and T1 and T2 values. So the activation energy can be evaluated if we know the rate constants at two different temperatures. By substituting in this particular equation, we can find what is the value of EA, which is the activation energy, and R is the gas constant. The SI unit value is 8.314 joule per mole per Kelvin. So the correct answer for this is option A. Next we have a question that has come in the year 97 related to finding the rate expression. The experimental data for the reaction 2A plus B2 gives rise to 2AB. So they have given the concentration of A and concentration of B2 and the corresponding rate values. We need to find what will be the rate expression. Means we need to find how the rate is depending upon the concentration of A and concentration of B2. So for this, the standard approach is we take any two data points where only one of the reactant is changing, and based on that change we will see what is the change in the rate of the reaction. So if you look at starting with, say for example, the first data point and second data point, what we have is the concentration of A is not changing, it is 0.5. Concentration of B2 is getting doubled. So when concentration of B2 is getting doubled, what we see is, because the ratio of the B2 concentrations in the second case, in the first case, the ratio of these two will be 2, and the rate values ratio is 3.2 into 10 power minus 4 divided by 1.6 into 10 power minus 4. This is also 2. What this means is when the B2 concentration is doubled, rate is becoming doubled, which means rate must be proportional to B2 concentration. So if you look at the second data point and the third data point, here B2 concentration is not changing, only the A2 concentration is getting doubled. From 0.5 it is becoming 1. But we see that the rate is not changing. Rate is as it is, 3.2 into 10 power minus 4. And this would mean that rate is not depending upon the concentration of A. So A power 0. So that means the overall rate will be equal to K into concentration of B2. So the correct answer is option C. Next we have a straightforward question based on the unit rate. For the reaction H2 plus I2 gives rise to 2HI, the rate of reaction is expressed as. So if you look at the definition of the unit rate is defined as rate of consumption of the reactants divided by the respective stoichiometric factors. Here the factors for H2 is 1, I2 is 1 and HI will be 2. Rate of consumption of reactants, which means minus delta H2 by delta T divided by 1 will be equal to minus delta I2 by delta T, this also divided by 1 will be equal to rate of formation of product delta HI by delta T. Here the factor is 2, so it will be divided by 2. So what we see is the correct relation for the unit rate will be minus delta I2 by delta T, which will be equal to, of course, minus delta H2 by delta T, which will be equal to half of delta HI by delta T. So the correct answer is option B. Next, a question that has come in the year 1996. The given reaction 2 moles of FeCl3 plus 1 mole of SnCl2 gives 2 moles of FeCl2 and 1 mole of SnCl4 is an example of. So here they want us to conclude whether it is a third order reaction or first order or second order or none of them. Now it is not directly possible to conclude what is the order of the reaction for complex reactions. So for complex reactions we will not be able to directly conclude the order without having the experimental data. But if the given reaction is an elementary reaction, then the overall order will be nothing but sum of the stoichiometric coefficients. This is only for the elementary reactions. And here though it is not mentioned in this question, the reaction given to us is actually elementary reaction. So here the stoichiometric coefficients are 2 and 1. So the overall order will be equal to 2 plus 1, which is equal to 3. Never mind, of late we don't get these kind of questions where we need to have pre-required knowledge about the reactions, whether the reactions are elementary reaction or complex reaction. In fact, we will not be able to directly tell whether the reaction is elementary or complex unless it is mentioned, because it is really difficult to remember various examples. But for this question the answer is option A, which will be a third order reaction. Next we have another question to predict the rate expression. This is a question that has come in the year 1994. The data for the reaction A plus B gives rise to C. A and B are the reactants. So they have given the concentrations of A and B and the rate value corresponding. We need to find out the rate law. So again, if you look at the given data points, so let us focus on first and third. First and third, B concentration is not changing. Only the A concentration is getting doubled. But the reaction rate is not changing. Means even though we change A concentration, the rate is not changing, which would mean that rate will not depend upon the concentration of A, which will be equal to A power 0. And if you look at the first and fourth data point, A concentration is as it is, B concentration is doubled. From 0.035 it is becoming 0.070. When B concentration is doubled, the rate is actually becoming 8 times. From 0.1 it is becoming 0.8. So the factor change in the B concentration is 0.070 by 0.035, which is 2, and the factor change in the rate value is 0.8 by 0.1, which is 8, something but 2 power 3. So what we see is the rate must be proportional to concentration of B to the power 3. Then only we will have for a factor change of 2 in the concentration of B, the rate will be changing by a factor of 2 power 3 or 8. So the overall rate law will be K into A power 0 B power 3. So A power 0 we can remove it, since A power 0 will be 1. So K into B power 3. So the correct rate law will be option C, which is rate is equal to K into concentration of B power 3. Next we have a theoretical question on the enzymes. By the action of enzymes, the rate of a biochemical reaction. So generally enzymes are the biocatalysts. So they are used or their activity basically enhances the rate of the biochemical reactions. They will speed up the rate of the biochemical reactions by lowering the activation energy value. So as per the Arrhenius expression, what we have is K is equal to A into e power minus activation energy by RT. So they lower the activation energy by altering the path of the reaction, and thereby the rate constant will increase and the rate of the biochemical reaction also will increase. So the role of the enzymes is to increase the rate of the biochemical reactions. Option B is the correct answer.